Hola, hi, this is Al, your statistics instructor. Let's get to work. In this video, we will talk about boxplots. A boxplot is a graphical representation of something called the 5-number summary, which consists of the smallest observation, the minimum, the first quartile, or Q1, the median, or the midpoint, the third quartile, also known as Q3, and the largest observation, the maximum. Boxplots show less detail than histograms and are very frequently used for side-by-side comparison of more than one distribution. Okay? A boxplot also gives an indication of the symmetry or skewness of a distribution, so it will be useful to assess normality. And as I mentioned in another video, we're particularly interested in determining whether or not it is reasonable to assume that a data set comes from a normal distribution, or that the observations contained in that data set are normally distributed. Okay, so let's begin. Before we learn how to do this using R, I really want you to understand what's the information that boxplot is giving you. What's the what it is that boxplot represents. Okay, we already mentioned that it's a graphical representation of 5 numbers, right? And but okay, we're going to talk about that in detail. So to do that, we are going to analyze this small data set. So we have 15 observations. These observations, these numbers represent incomes. Okay. So, as I said before, a boxplot is a graphical representation of 5 numbers. One of those numbers is the median, or the midpoint. Okay, so to find this guy, right, what you could do is use the following formula, okay, to find the location of the median. So first, you have to arrange your observations from smallest to largest. Okay, n represents the sample size, and then using these, using that formula, n plus 1 divided by 2, you are going to be able to find the midpoint, the location of the midpoint. And then what you have to do is count to locate that observation, right, in the ordered list, and then obtain the value of your midpoint. Make sense? So for instance, let me give you a very simple example, right? Say that let me create a vector with 5 observations. Okay, so it's already ordered from smallest to largest. The median is, in other words, the midpoint, right? So clearly the midpoint is going to be 30 in this small data set. In this case, n, the sample size is 5, right? So n equals 5. So if we use that formula, m plus 1 divided by 2, that is supposed to give us the location of the midpoint. Let's see if it works. So n plus 1 divided by 2, so that's 3. And then that is the location, right? So to actually find the value of the median, of the midpoint, which we already know is 30, what we have to do is, oh, this is the location. So we count 1, 2, 3. So is the third observation in the ordered list. And then m, in this case, the median would be 30. Make sense? Okay? Okay. So, we did something similar here, right? Let's enter those numbers. So let's call it income using that C function, which stands for concatenate, right? So we have 110, 25, 50, 50, 55, 30, 35, 30, 4, 32, 50, 30, 32 again, 74, and 60. Okay? Now, we need to know to apply that formula and locate that guy doing things kind of by hand, right? We need n, the sample size. So we could use this function. Length is going to give you the number of elements in this object we created, income, and you could use an equals sign to make an assignment in R. So meaning length of income is going to be saved, is going to be stored in this object that we called n. Okay, so n is 15. In this case we already knew that we had 15 observations, but okay, so it seems that we're on the right track. So now if you want to make a comment, something that is going to make your code more readable, you can do so by typing a hashtag, and then whatever follows is going to be ignored by R. So we're just reminding ourselves that the formula for the location of the median is n plus 1 divided by 2, right? Okay, so let's find the location. So the 8th observation, but we need that information, we need these observations in order from smallest to largest. Okay, so what we have to do is use the function sort, and that is going to do the trick. That is going to arrange our observations from smallest to largest. And now if we want to find m, the midpoint or median, we just count 1, 2, 3, 4, 5, 6, 7, 8, right? Or we could do something like this. We use the square brackets and the number of the observation that we are interested in. That's our guy, the 8th element of the new version, the new version of income is the one that is arranged from smallest to largest. Make sense? Okay, so 35, that's our median. Okay, and here we have that. Okay, so remember that n plus 1 divided by 2 is the formula for the location, where the median is, but not the actual value. Okay, because for instance here the location is 8, but the value of the median is 35, right? Meaning 35,000 would be you know, the center of those incomes. Okay, okay, so we have one of those 5 numbers, the median, but the box plot is a graphical representation of another 4 numbers. The minimum, well, it's kind of a self-explanatory as the maximum, but what about Q1 and Q3? Okay, so Q1 and Q3, which stand for the quartiles, the first quartile and the third quartile, okay, Q1 is an observation such that the first 25% of the data set lies to its left, and Q3, right, is the observation such that the first 75% of your data set lies to its left. Okay, so one easy way of finding Q1 and Q3 is just thinking about them as, in the case of Q1, as the median of the first half of your data, and Q3 as the median of the second half of your data. Make sense? So in this case, right, let me save this version, new income, let me call it. It's income, but arranged from smallest to largest. Okay, and let's find Q1. Okay, so new income is this. We already know that the 8th observation is the median, the midpoint, which makes sense, right? We have 15 observations, so the 8th is the one right in the middle. Okay, so the first half of the data, if we exclude the median, has 7 observations, right? So if we have 7 observations, let me call that guy N1 to the number of observations in the first half of the data, excluding the median, right? So it would be 7. And what we said is that one easy way of finding Q1 is just thinking about it as the median of the first half of your data set. Okay, so let me just say that the location of Q1 is going to be given by N1 plus 1 divided by 2. Okay, so let's see. So it's the 4th observation, right? So it would be 1, 2, 3, 4. Q1 would be 30. Okay? And then for Q3, we would do something similar. Again, we have that the 8th observation, which is 35, represents the midpoint, and then on the second half we have, excluding the median, right, we have these guys 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4, 5, 6, 7. 7 observations as well, right? Makes sense. So if n2 represents the number of observations on the second half excluding the median, then we would get the same thing, right? If let's say that we call it n2 to the number of observations on the second half, so 7, then 7 plus 1, 8, divided by 2, 4, so it would be 1, 2, 3, 4. Q3 would be 55. Make sense? Okay, so there we have Q1 doing exactly what we did, and Q3. Okay? Okay. And again, maximum and minimum. Minimum 4, maximum 110. Okay? So now we have our 5 number summary. Make sense? Minimum, Q1, M, Q3, and maximum. And the box plot is nothing but a graphical representation of those 5 numbers. Okay? Okay, now let's try and do this using R. Okay? So we already have income. Okay? So if you want to find the 5 number summary using R, all you have to do is use the following function, 5num, and then the name of the object or the dataset that you are interested in. Now note that Q3 is slightly different. Okay, so don't worry, this happens sometimes because R uses a different version of Q1 and Q3. They call them the hinges. I'm going to be including a bit more of a detail about how you define the hinges, so you know what's the formula that R is exactly using to come up with these 5 numbers. But anyway, what I wanted you to understand using this, the version that we talked about, is that the median is the midpoint, meaning the observation that is right in the middle is the center of your list of observations arranged from smallest to largest. And that an easy way of thinking of finding Q1 and Q3 is thinking like this. Hey, Q1 by definition is the first quartile, meaning the observation that has the first 25% to its left, and Q3 is the observation that has the first 75% to its left. So if the median is the midpoint, that means that 50% of the data set is to its left, right? So if you think about the first half of the data as it's as a separate sample, then finding the median of the first half is going to give you Q1, right? Same applies for Q3. Okay, anyway, and let's keep going here. So now we have those 5 numbers, but Now we want the graphical representation, which is the box plot. Okay, so it's really easy, right? Let me show you the basic box plot using base R. By the way, well, okay. Okay. So here we have 4. Here we have Q1. This guy here is M, the midpoint, the median. This guy here is Q3, and this guy here is the maximum. Okay? At some point we're going to talk about what these guys mean. Okay? But anyway, make sense? Okay, so let's talk about something we had talked about before. Okay, let's talk about the box plot for another data set. Remember that R contains built-in data, right? So if you want to find out you know, if you want to learn more about which data sets are included in base R, all you have to do is just type data, then open and close brackets, and there you have the list of those data sets. Remember that in another video we talked about this data set, faithful. It must be here. Yeah, there it is, right? Okay, so and again, remember that if you want to learn more about particular data set, you'll get its description by typing help and the name of the data set. Okay, so we have used this data set before. Let's create a box plot for the variable, for one of the variables. And remember that if you want to know the names of the variables contained in a data set, all you have to do is type names, and then you'll get the names of the variables inside that data set. So in this case I would like to play around with the first one, with eruptions. Okay, so let's make a box plot for eruptions. Again, remember that if you want to isolate one of the variables contained in a data set, one way of doing so is this. Name of dataset, $, and then the name of the variable you are interested in. Okay? Got it? But now you know that this guy here is the minimum, this guy here represents Q1, this guy here represents M, the median, this guy here represents Q3, and in this case the maximum is here. Okay, so again, minimum, Q1, median, Q3, and maximum. Okay, okay. Now, if you wanted to make that box plot look nicer, let's try and do that. let's try and add a main title. How about that? So duration of Old Faithful eruptions. Let's also include a label for the horizontal axis. The X label will be duration. Label for the vertical count, and let's make this guy blue. Okay, so a nicer version of your box plot. Okay, so as I mentioned before, there's a very popular package, an R library to make graphs called ggplot2. So let me show you how we can make a box plot using that popular R package. So remember that I already have installed that guy with the command install.packages and then the name of the package that I want to use, ggplot2, right? So that I already did a while ago, but now every time that I want to use it, I have to load it. So to do that, just use that command, library ggplot2. In this case, that's the library that's the library or R package that I want to use. Okay, so let's make a basic version of a box plot using ggplot. So ggplot, that's the first command. And remember, first we need the data that we want to analyze, in this case faithful. Then the next argument is mapping with aesthetics, right? And in this case, one way of doing it is on the horizontal axis we don't want anything but for the vertical axis we're going to be using eruptions. Okay, and that, remember, if we just typed that, we just get the canvas, nothing more than the canvas. But if you want to add to that canvas the box plot, you need to add a layer. So let's add that layer. That layer is going to be geom, right? And then boxplot, open and close brackets, and that gives you the basic version of a box plot using ggplot2. Okay, now let's make it look nicer. Let me recycle what we had before, and now what I would like to do here is, instead of what we had, I would like to add that horizontal line right at the beginning where you have the minimum, and at the end where you have the maximum. So to do that, what I'm going to be doing is adding this layer stat underscore boxplot, then geom, and then to add those horizontal lines where the minimum is and where the maximum is, right? I'm going to be using that option, geom equals error bar. and I would also like to modify the width of the box. Let me see what happens if I use 0.25, then plus and geom underscore boxplot, open and close parentheses. Let's see what happens. Okay, see, so now we have these horizontal lines. Okay, and to do that we used this additional layer, stat underscore boxplot, and that option, error bar. And this width is going to help you change the width of your box. Okay, so let's make a couple more changes. It turns out that some people like their box plots on horizontal instead of vertical. So let's see how you can do that. Okay, so to do that, to have a horizontal box plot, all you have to do is add this layer chord flip. So you flip the coordinates, and now you have this. Make sense? So the default is having a vertical box plot, but sometimes, especially when you have a lot of data sets that you want to compare, it's sometimes nicer to have these box plots drawn horizontally. So anyway, you accomplish that with this, with chord underscore flip. Okay, so how about we make a few changes to make it more colorful. Okay, and let's add a main title and a title for horizontal vertical. Okay, let's try and do that. So remember, ggplot is just going to help you to prepare to set your canvas. With this, what we did is we added those error bars to our box plot. With this, we are actually drawing the box plot, and with this we're flipping the coordinates, right? The x and y axes are switching places. So now we said we would like to add color to our box plot. So here I'm going to change this color. Let me use black for the border of my box plot. Let me do it like this. I want, okay, so black for the border, but for the box what I want is blue, so I'm changing that color there. We are drawing that box plot horizontally, and now we want to add some labels. Remember, we have used this before, that command labs as in labels. Remember that if you want a main title, it's just title duration of old faithful eruptions. Now let me add a label for the x-axis and one for the y-axis, and yeah, that's it. Okay, so before we summarize I want you to note that the syntax to create a histogram in a box plot are very similar, right? So first we prepare our canvas, and then basically the basic version of the box plot, right? If we go back to the very basic one, right, is this. So you have your canvas, you prepared your canvas, and then just geom box plot. That's very similar to the one for histogram. First you prepare your canvas, and then instead of having geom box plot, you have something slightly different, right? You have geom underscore histogram, right? But see, so that's why this our package, this library, has become so popular, because it's very consistent, right? There are just a few differences to create different graphs. Okay, anyway, and the same thing can be said about this, right? If you want to add those main titles and titles for the horizontal and vertical axes, this is the this one here, this is the exact same command that you would use if you wanted to add those titles to a histogram, right? Okay, anyway, so let's summarize. What we have talked about in this video is box plots. A box plot is a graphical representation of 5 numbers, the 5-number summary. And the 5-number summary are the minimum, Q1, the median, Q3, and the maximum. Okay? And these graphs, as you could see, they are not as detailed as histograms, right? But they are going to be very useful to judge whether or not distribution is symmetric. So for instance, in this case, we can see that this is not a very symmetric distribution. Let's see the nicest version that we had here, right? The horizontal one, right? Clearly, right? This is not, income is not a very symmetric distribution, right? It seems to be skewed. And we are going to be using these graphs to judge symmetry, because that's one of the features of a normal distribution. So these guys, box plots, are going to be another one of our tools to assess normality, graphically speaking. Okay, so that's it for now. Thank you so much for watching. Please take care and keep working hard. See you next time. Bye.